Why does
Why
it
does it
go
go
from
531?
531?
Jeez.
Because this is an honors class, it's accelerated.
Did it always
I
do
get
that?
it.
I don't think it did do that before.
No, it didn't.
Oh.
It's probably broken. Tyler, what's a ratio?
It's the amount of one value compared to another value.
The amount of one value compared to another value. For instance,
3 to 1.
okay, but what are those things? Just 3 to 1?
Numbers.
No, numbers, okay. So you're just comparing the number 3 to the number 1.
I guess.
Okay, Sarah, you got an example for me? And don't just tell me 4 to 7.
Like students in one class compared to another class.
Okay, good. Zach, what do you got? What would you like a ratio of?
Trucks versus cars.
Trucks versus cars, like in the world or on the highway at a certain point in time,
That's
or
up to the
in your
person.
in your Hot Wheel collection, or
That's up to the person comparing them.
well, you're comparing them. What
And I'd go with the Hot Wheel collection.
Hot Wheel collection?
Mhm.
So would you say you have more cars to trucks or more trucks to cars?
Probably more cars.
More cars. What do you think that ratio is?
Ooh, I don't. That'd be a big number. I don't know.
How are you defining a big number?
Like between 100 and 200.
Okay, so 100 to 1. You have 100 cars for every truck in your Hot Wheel collection. I keep saying Tonka, but you guys even know what Tonka is?
Yeah.
Okay, just
That was
checking.
my
Just
first-
checking.
That was my first. Like,
Gamekeeper.
that's how I learned to walk.
Yeah. Were your Tonkas plastic or metal though?
Metal.
Yeah, ours were metal too. Good chance for tetanus.
It's like the end of the.
Yeah, they would rust, with a sharp edge on them. Then you try to ride them down the driveway, and that would never end well. So you want 100 to 1 cars to trucks?
Well, it'd be. It'd be like 50 to 1.
50 to 1.
Yeah.
And how would you express that ratio?
What do you mean?
How would
what
you
it
write
look-
that?
What would it look like?
Yeah.
50 colon 1.
50 colon 1. Could you express that in any other way?
Fractional.
Fraction. 50 over 1. 50 is the numerator, 1 is the denominator. Any other ways?
Not that I can think of.
What do you want?
50 2 1. Not 2 0. T 0 1.
2-0. T-O. You're combining letters and numbers into a completely new language. Okay, so comparison of things. Tyler started by talking about comparison of numbers. For the most part, we're going to compare numbers. We're comparing quantities of things. So even when we compare trucks to cars or cars to trucks, we're still comparing the quantity of cars versus the quantity of trucks. And we talked about some. So I had boys to girls in the classroom, freshmen to seniors, and then wingspan to height. You know what your wingspan is?
Your height.
Yeah, it's your height. This is a ratio, usually, unless,
Mine's different.
Of course,
Okay, well, I'm really unnaturally.
is your wingspan larger than your height, or is your height
Yeah, my
larger?
wingspan's larger.
You got big old gorilla arms?
Yeah.
That happens sometimes. Okay, so we got the fraction, we got the colon, and we got the 2. 2-0. Hey, solve this problem. The perimeter of a rectangle is 60. The ratio of the length and the width is 3 to 2. Find the area of the rectangle. So the first time we're doing this, you might struggle a little bit, but eventually you'll understand how these problems work. Set up an equation, solve the equation, answer the question. You might want to draw a picture. For future reference, by the way, this is called an extended ratio problem. Some of you drew very nice rectangles and then stopped. Can't be 3 and 3 and 2 though, right? So 3 plus 2 is 5 times 2 is 10. Okay, and then what? Okay. Okay, and then So walking around, I'm seeing a lot of people drew a rectangle, then they labeled the sides 3 and 2, and that doesn't work because obviously 3 plus 2 is 5 times 2 is 10, which is not the perimeter. So we need to find a constant in there, not constant, a variable in there that will allow us to solve the problem. And Zach's going to show us how it's done.
So this one and then
Yeah, then pick a color.
blue.
Okay.
Ooh. Rectangle. And then I don't think I've ever been up here before. So the ratio's 3 to 2, so I just put.
That was cool.
Does it matter?
Nah, it's okay.
Okay.
We know.
So here we go. 3x, 3x, and then 2x over here, and gosh,
It might not be you. It might just be the pen acting wonky. I might need a new battery.
it's the pen.
Okay then. I guess it's the pen.
Okay, and then
All right, hold on a second. So it's the sides are not 3 and 2. The sides are in a ratio of 3 to 2. So he introduces variable x to stand for that thing that multiplies by 3 and by 2. Carry on, sir.
And then so, what did I do next? I added them all up and set them to 60, which is 10x equals 60, and x equals 6, and then it's asking for the area, so you have to multiply 6 by 2, which is 12, and then this is 18. Come on. And then I got what's 12 times 18? I got like 219, something like that.
Start with a blank formula. What's the formula for the area of a rectangle?
Well, it's 12 times base times height. So it's,
Right, so right area equals base times height. If you're gonna do it right.
that's right. Does it matter if it's capitalized? Or?
It does, it should be lowercase.
Okay.
We'll learn why in a couple chapters.
And then wow, that was awesome.
Isn't technology wonderful?
And what's 12? Is 219?
Okay, well, 10 times 18 is 180.
Mhm.
18 times 2 is 36. 180 plus 36 is
260.
attaboy.
And then that's
216 what?
erase.
No, don't erase, just write it.
Units. Does it say?
It does
Oh,
say.
come on. Centimeters squared.
Alright, let's keep it up.
Hey!
So again, it doesn't tell you that the side lengths are 3 and 2, it tells you that the ratio of the side lengths are 3 to 2. So in this case, it's 18 to 12. And when you reduce that fraction, or that ratio, which by the way, you should always reduce your ratios, you get this ratio of 3 to 2. So he introduced that variable that he uses, and that's why it's called an extended ratio. You extend the ratio to get this variable, or this statement, and then you work it all out and make sure you answer the question. So this particular question asks you for the area of that rectangle. 216 centimeters squared, well done. Turn that off, make it quiet. Okay, number 2, solve that one now. Now that you've seen how an extended ratio problem works, this should be quite a bit easier. Let's be back about getting out those calculators. Jack, what do you got?
Let me see the answer.
No, send it to me telepathically. Did you pick up on the sarcasm there, buddy?
I did.
Excellent.
Okay, so. Alright.
What do you got for the three angles?
36, 54.
How do you do? Yeah, good. Explain it.
Okay, so I drew out a triangle and marked each angle. Not one angle was 2x.
Good.
Next was 3x, and the last one was 5x.
Uh-huh. And what do you know about all three of those angles?
They are equal to each other.
They are not equal to each other.
Yeah.
Right. Is that what you said? You said they are not equal to each other, right? So what do you know about those three angles in a triangle?
Alright. So what did you write?
Well, you solved the problem. What did you write down?
Oh, I thought you were joking.
What do you think? I was just firing off trivia questions? Okay.
Wait, so what do you want me to do?
Tell me the equation you wrote on your
Okay.
paper, right there in front of
10x
you.
equals 180.
Good, because the three angles in the triangle add up to 180 degrees. And x turned out to be
18.
good, and then you plugged it back in to find all the angle measures. Okay, well done, Jack. That took way longer than I thought it would.
He was inches way there.
All right, so now we got ratios under control. The next question then is, Patrick, what's a proportion? If a ratio is a comparison of things, what's a proportion? Or, can you give me an example of a proportion?
There's no like, is it kind of like, so I want to say comparison, but like,
So it's not a comparison? Or it is a comparison?
it's not.
It's not, okay. Where would you use a proportion, or where have you heard the word proportion? No? Carter? You waving your hand around?
I don't know. Is it parts of a whole, like fractions? Like a part? What part of the whole it is?
So how is that different than a ratio?
It's not comparing. It's not being compared to like another thing. It's just being compared. It's,
So give me an example of how you would use a proportion then.
I don't know.
Somebody had their hand up over here. Nicola,
Salt to water. Salt to water.
once more.
Salt to water.
Salt to water. Okay, so how is that not a ratio?
It is.
It is. So then a ratio is a proportion?
Yes.
It's the same thing? Max?
Is it like when when the ratio like is equal, like 1 to or 3 to 3? I don't know.
That would be a ratio.
Yeah, but it's proportional because both of them are equal. I don't know.
Oh, I see what you're saying. No.
Alright.
Proportional applies to proportions, not to ratios.
Yeah.
Jack?
You just have to do percents.
It could, yes, but doesn't have to.
Is it like a denomination of a ratio so it's like a more specific ratio?
A denomination of a ratio that perpetuates itself by the ramifications therein. What?
Denomination isn't that big of a word.
I understand, but when you're simple like me, it's a big word. I'm afraid of
So-
multisyllabic
okay, so
words.
So, this, I don't know how to say this. It's like a more specific type of ratio. Oh, it's a comparison of ratios.
Good, it's a comparison of ratios. So ratios compared things, and now once we have two ratios, we want to use those ratios and create a comparison between the ratios. Now, where would you use a proportion? Okay, well, using some language that Max used, he used the term proportional. Proportional means that you have a proportion that's true. And if we have a proportion that says, for instance, the ratio of boys to girls in this classroom is true for the entire freshman class, we can then go and calculate the number of girls, for instance, in the freshman class based off of what we have in this class. Or I have some other examples for you. 7 pencils cost a quarter. How much will 400,000 pencils cost? Okay, set up a proportion, solve, and we'll solve these in a minute, so don't worry about it. There's the boys to girls example. And again, that's based on the fact that they're proportional. Just because we have a ratio of boys to girls in this classroom doesn't mean that same ratio is extended to the whole school. But again, in order to discuss the problem, we're going to assume that this class is proportional to the entire building. This is a moose. So here's a general form for a proportion. A over B equals C over D. There's a reason why the A and the D are blue and the B and the C are red. The A and the D are called extremes. So the upper left and the lower right are the extremes. And the lower left and the upper right are called the means. M-E-A-N-S. Okay, we good? There's a definition of proportional. Thank you, Max. If that proportion is true, then they're proportional. 2 over 3 is equal to 4 over 6. That's proportional. 2 over 3 is equal to 8 over 42 is not proportional. Yes, sir?
Is there like why are those two means and extremes? Or you explain it?
Why are they called the means and extremes?
Yeah, like what do they have to do with each other?
I don't know the origin of the terms, why they're called extremes and means, but the reason they have names is because we're going to look at some properties that tie extremes together, means together. So I think I'll answer your question in a couple slides. But again, why it's called the extremes and the means, I have no idea. There's probably some weird math reason for that. Okay, so the product of the extremes equals the product of the means. If you look at that proportion that you have sitting in front of you, and look at that sentence, the product of the extremes equals the product of the means, what do you know that as? Cross multiplying is correct. Okay? So if we start with A over B equals C over D, then AD equals BC. You know that it's cross multiplying. We're going to cross multiply a lot. So extremes, multiply the extremes together, multiply the means together, set them equal to each other. Is it safe to assume you can all cross multiply?
Yeah.
Good. Next property, the reciprocal property. Flip over one side, that's fine as long as you flip over the other side. That's just basic algebra. Whatever you do to one side of the equation, you have to do to the other side of the equation. I don't even know if you need to write that down, but you can if you want, because it's a merg. Okay, let's. Let's get to some examples. All right, tell me how much 400,000 pencils cost, please. Because you can never have too many pencils. Oh, we lost Maddie too? Oh. Where'd Maddie go? Yes, sir.
I just have a question.
Certainly.
So couldn't A and D also be the means if you can switch them?
Yep. is Wintermute first period? Why? I don't understand why the two of them moved.
Yeah, I was supposed to.
I switched back.
I was supposed to move too, but then I switched to Joel.
Yeah, that's what I did.
Yeah, it means the same.
We got room in the class. They could come
Yeah.
back.
Four
Caitlin
seats.
can come back.
They could come back.
Caitlin can come back.
Yash, is that right?
So I
What do you got?
early.
I think $14,286.
$14,286.
That's why
That's what I got.
That's a lot of money.
well, it's
All right,
that's-
so tell me how you set that up.
Divide
Nope.
14,000 by 7.
Nope. Sorry, Brandon.
Did you set up a proportion? Okay, then I don't want to talk to you. Who set up a proportion, Rich?
What?
Yeah. You set up a proportion to solve this?
Not exactly.
Wilma?
When the proportion be 0.25 over 7 equals x over 400.
Is that right?
Anybody else set up a proportion differently? What'd you do?
Shouldn't the money be on the, never mind.
Does it matter?
Glad I could help.
Doesn't really matter, right?
Well,
No, never mind.
'Cause if-
she compared money to pencils equals money to pencils. Is that legal? Did you get the right answer first of all? So obviously it must be legal.
Couldn't you do pencils over money too?
Well, it's the same
Okay,
thing.
could you
The
do
circles are equal.
could you do pencils over money equals pencils over money?
Wouldn't it be the same thing because the reciprocals are equal?
She just answered the question. You flip it over, it's cool. How else could you do it? Could I do pencils to pencils equals money to money?
No.
7 pencils over 400,000 pencils equals 0.25 over x. Does that work?
Yeah.
Sure. Here's the tough question. What doesn't work? Alan.
Does 7 over x and 25 cents over 400,000 not work?
Pencils over money equals money over pencils. Not good. Okay, so you have a couple options of how you can set it up as long as you keep things the same. Now, by keeping things the same, I mean that notice in the first one, the money's on the top, the pencils are on the bottom. The second one, pencils on the top, money on the bottom. That's okay. And the third one, pencils over pencils equals money over money. It's fine. All three of those work. You just can't randomly flip one of these over because they still have to match going across and up and down. So notice that when I did money over pencils, this money ties in with that pencil. This money ties in with that pencil. If we go to the other one that we did, this pencil ties in with that money. Those pencils tie in with that money. Cross multiply and solve. I'm going to require that you set up a proportion for each of these problems. Even if you have some other method where you multiplied or you took 7 and divided it by 0.25 to figure out how much each pencil was and then multiply that by 400,000, I still want you to set up a proportion every time. Okay, let's figure out then how many, what are we doing, girls? No, how many boys there are in the school.
Is that true? Like, are there actually 10 boys and 11 girls?
In this class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 boys and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 girls. What did I say, 13 boys? 13 to 12. I just made numbers up. I didn't actually go through it.
You should.
I should have, right? If I was a good teacher, I would have gone through the roster and actually. You should. Rosie, what do you got? Okay. We'll wait. Question?
If you say you got a decimal answer, would you like count the extra person, or would you just have that decimal of a person.
You have a decimal person?
So you have like half.
You have part of a person.
Yeah.
That's illegal in most states.
You just have like nothing.
So would you include that part of a person?
Probably not.
Or would you make them a whole person? Or would you just kick them to the curb?
Probably just.
Let's see what Rosie did. Rosie, what'd you do?
I put I put 11 over 10 times x over 850, and then when I cross multiplied, I got 10x equals 9,350, and I divided both sides by 10 and got x equals 935.
935? Yes, no? Give me your proportion again, Rosie.
11 over 10
Okay, so girls over boys equals,
x over 850.
there's your problem.
Oh, I
This is
flipped
girls.
it. I flipped it.
Yep. Okay. So when you cross multiply this, what do you get? How much? 772 point 727272. All right, so Zach, you're asking about that almost 3/4 of a person. So are you suggesting we round up or round down?
Probably round down. 'Cause
Why?
We can't create the rest of the person.
So you're gonna treat that person as someone inferior and just kick them out?
Yeah.
Okay, I'm okay with that.
Or
You should
or
round down.
or maybe their arms and legs got like cut off for some reason, like in the accident. It's possible.
Are you calling me less of a human?
No, they can still
Okay, I
be
just wanna
human
make
that
sure
way.
you're going this route. So you're saying if I have no legs, I'm less a person than you?
Well, it was,
I just wanna know that, it's a yes or no question. You're saying if I lost my legs in a freak train accident,
physically,
then I would be less a person than you?
Physically, I guess you would be, because you'd actually like lose body mass. But other than that, no.
So if you lost your arm right now, you would not be a boy anymore.
That's a big
That's a pretty big jump. It's not his arm, he would have to, never mind.
Take it away because
Maybe I'll record third
you'd
period.
be less boys in class.
Yeah, this is gonna be a best reading.
This is going in compilation. This is going in the best reading compilation.
So, what's the agreement here? Are we gonna round up or down?
Down.
Round down, yeah, so we would just get rid of this person. Or that part of a person. As if they didn't have a bad enough life, they'd lost their arm and leg and Zach just kicked them out.
Good going, man. Not bad.
Okay, real simple last example, solve for y. Doesn't tie to anything, just a straightforward algebra problem. Using the means extremes product theorem. Erica, what do you got?
Y equals
4.
Yeah.
I got that too. Anybody not get 4? Good. So you have to remember to distribute the 2 to the y plus 2 when you cross multiply. There's another moose for you that says do your homework. Okay, so the assignment is in Schoology. It's day 1, chapter 7. And the assignment sheet is on that Schoology page also. So you have an idea of what's going on. And then we just continue on with bigger and better things. Any questions?
Yeah, why was the
Why
moose
is the
halfway
moose?
through the slideshow?
Why
Are you
not?
dissing the moose?
No, I'm just
Okay.
wondering, like,
It was
is that like your new favorite
Friends.
animal
No.
or something?
No, it's not my favorite animal.